Hey, hello everyone. Welcome. It is time for us to go over this most recent lesson, just our quick little set of problems here. So just an update so you guys can hear it before I start. Hopefully by the time I post this video, you will actually already be able to log in to your school email and Canvas accounts again. You will be required to reset your password. They're being a little obnoxious with their password requirements, so make sure you're typing in a rather long password, that it has capitals, lowercase, special characters, all that kind of thing. And if you need help, I believe Mr. Bloss will have the WebEx going for you to get some technical help, or you can send me an email, either to that new temporary one or to my actual email. Either one of those will be fine. Just try to get into contact with me if you need it. You could even leave a comment over in YouTube and I'll figure out how to get to you if you really need the help. All right. Anyways, let's just go through this really quick. Shouldn't take too long. Make sure you have those notes out. I kind of designed this to be done with minimal calculator usage. Hopefully it was a decent review. Let's check it out. So number one here. So the key here is realizing that that guy on the right-hand side can be rewritten as 6 to the third power. And now once both of those guys have exactly the same base, you're going to be able to set them equal to each other, those two exponents. So 2x is equal to 3. Divide both sides by 2, and you can have a fraction answer or a decimal answer. Either one of those is fine. And if you want to show the work, right, divided by 2, that'll work as well. All right, check out problem number 2. So on problem number 2 here, they already have the same base, which is kind of nice. You just set them equal to each other immediately. This is like a Algebra 1 question almost, or algebra, or pre-algebra even. Now that set them equal to each other nice and quick. And then I like doing a little switcheroo, move this guy to the left, move that guy to the right. So negative 2v minus 3v equals, keep that 2 there, minus 1. Negative 5v equals 1. Divide both sides by negative 5. V equals, you can write the fraction answer or the decimal answer. Same exact thing. Let's keep it moving. Keep it moving off to problem number 3. So on problem number 3 here, first step is to rewrite that 9 as 3 squared, so they have exactly the same base. And you solve like we've been doing. 2p plus 1 equals 2. Subtract 1 on both sides. I guess I can just start showing all the work on this one, not a big deal. Just because I hadn't on the previous ones, and now all of a sudden I will. Be nice to see it. And therefore p is that 1/2 or that decimal version of 0.5. And you kind of just keep doing the same thing. It shouldn't be too much effort until we get to that second page, and that second page has some problems that are a little bit more beefy. So here we can just copy that left-hand side. The right-hand side, that 64, can be written as 4 to the third power. Set those two equal to each other. Move the m to the right, the 3 to the left. 1 minus 3 equals m. Negative 2 equals m. So this one there was no division. We had to do exact answer. Starting at number 5, we do need to change both sides of the equation because we don't have the nice quick fix. So here that 36 needs to be written as 6 squared to the negative x. And then that 216 needs to be written as 6 to the third power. Power of a power, you multiply exponents. So 2 times negative x is negative 2x equals 6 to the third. And now, nice and easy. Great. This problem is a little bit funny because we have so many dang zeros on it. So let's see, how many zeros do we have? We have 1, 2, 3, 4, 5, 6. I think it's most natural for students just to go to powers of 10 immediately. So even though you could just say this guy is 100 to the third power, I think it's more natural for students to rewrite this as 10 squared to the 3b plus 1 equals 10 to the 6th power. However, again, if you had already did 100 to 3b plus 1 equals 100 to the 3rd power, you'll get the same answer. So 10 to the 6b plus 2 equals 10 to the 6th. 6b plus 2 equals 6. Subtract 2 on both sides. Divide both sides by 6. You get 2/3, or the decimal version of 0.667. Easy peasy. Let's go to that second page. All right, so starting on this one, now we have a little bit of harder problems. We have to use our our like terms and adding exponents, and the next one we got to convert and add exponents, all kinds of stuff that we got to do here. So let's try it out. So on the left here, we're going to go ahead and add those like terms. So 3 minus 3x plus 3 minus x. So it's going to be 3 to the 6 minus 4x equals 3 to the negative x. And again, now it's an easy question. 6 minus 4x equals negative x. Move that 4 to the right-hand side. Negative x and 4 is 3x. Divide both sides by 3 and you get 2 is equal to x. Not too bad. Not too bad. Check out problem number 8. So this one is one of the longer ones, not as long as number 10, but definitely one of the longer ones. Everything needs to be written as a base of 5 to keep it all going. So 5 to the negative 2, 5 squared, whoops, the negative 2k times 5 to the 3rd power equals 5 squared to 2k. Power, you multiply exponent, so 2 times this guy, we got 5 to the negative 4k times 5 to the 3rd equals 5 to the positive 4k. You multiply like terms, you add the exponents, so add the like terms. There are no even like terms, just 5 to the negative 4k plus 3 equals 5 to the 4k. Set those two equal to each other, and then it's an easy question. Going up here, adding the 4k, we got 3 is equal to 8k, divide both sides by 8. And you get 3 over 8 is equal to k. You can also write the decimal version of that answer of 0.375. Number 9, they were nice enough to give you like bases already, so there wasn't too much extra effort to go through. So 5 to the 3p, and actually the negative 2 and the positive 2 cancel. And now you just go ahead and set those two exponents equal to each other. Move that negative 2p to the left-hand side. Becomes positive 2p for a 5p equals negative 3. Divide both sides by 5. And p is equal to negative 3 over 5, or negative 0.6. Finally, number 10. So this one definitely is a little bit more difficult, only because we have to do something with this divided by 64. So there's actually 2 good options to this problem. I'm going to go through both of them, just so that you have both of those at your disposal. However, regardless of what you decide to do, the first step is pretty much going to be the same on both questions. So at least at step 1, it will be the same. And step 1 is to change everything to a base of 8. So it's going to be in parentheses, that same parentheses there, 8 to the negative 1, k minus 2. So negative exponent changes that fraction. Divided by that 64 needs to become an 8 squared, and this 64 needs to become an 8 squared. And this is where there's kind of two options that you can do. One, well, actually, multiply this out first, sorry. 8 to the negative k plus 2 divided by 8 squared equals 8 squared. So at this step, again, there are 2 good options here. My preferred option is to remember the exponent rule of when you're dividing like terms, you're subtracting the exponents. So negative k plus 2 minus 2 is just straight up 8 to the negative k equals 8 squared. It's kind of like that. Those 2's kind of cancel out basically. And therefore negative k equals 2 and k equals negative 2. However, if you forgot that rule, you could have also done your like a cross multiply of sorts where you kind of divide this by 1 and then cross multiply. Or you remember my rule that if you have a over b equals c, you can simplify that to a equals bc. Kind of just multiplying that b up there, and that would give you 8 to the negative k plus 2 equals 8 squared times 8 squared, which is 8 to the negative k plus 2 equals 8 to the 4th. You can't see what I'm writing because my face is covering it. And now, again, easy question once you've gotten to that step. So hopefully it wasn't too intimidating, but either way, you get k equals negative 2 for your final answer. All right, hopefully you're able to check your work with this nice short little video, and hopefully you're enjoying your effectively extended spring break here. Have a good one, guys. I will see you either Monday or Tuesday, depending on which class you're in, and looking forward to it. Have a good one. Bye.